Hey, what's going on, folks? It's Mike here, and welcome back to the Programming Language First Impression series, a series in which we take a look at a programming language for about an hour that I previously haven't looked at and just investigate that language, get it set up, show you how to get started as a beginner mindset would, and go ahead and look at the ecosystem around that language. So with that said, for today's language, I want to go ahead and just look at something interesting that popped up in the news here recently. And if you'll notice here on the TOB index, which is sort of a metric for how much code there is in a particular programming language or how popular. Again, it's not clear exactly what that algorithm is. So again, take this for a grain of salt, meaning that it doesn't necessarily mean that one language is popular or better than any other way, but it is an interesting list to look at every once in a while. In particular, because of this headline here, that for the first time in history, C++ has passed the C programming language. Now, I don't know why that is, or if there are more just repos or searches or tutorials or something, or whatever the metric is for these rankings, but it did kind of give me an idea that maybe we should look at some of the C++ successor languages. So for today's language, I'm excited to announce we're going to look at Cppfront, which is a personal experiment on C++ by Herb Sutter, and it's one of the so-called successor languages. So I want to give a little bit of context here because I have a little bit of insight into the C++ community just because I've been working in it for a long time. I tend to go to conferences that are C++ related, as that's kind of what comes with graphics and gaming and some of the stuff that I've worked in professionally. But what's sort of interesting about this, we'll go ahead and dive into Cppfront here. Or actually, let's go ahead and just open up one tab here, is that this is a language very much in development. In fact, of the languages that we've looked at in this series, this is probably the one that's most in development. And again, it's a bit of a experiment here. So we're going to look at it the best that we can here. And I think it has an interesting story to it. So again, Cppfront is a compiler from experimental C++ syntax, Cpp2. And basically the idea is to kind of, what this repo is for, is to kind of prove out some concepts, share ideas, and prototype features that could also be proposed for C++. So this isn't to say when we say or talk about some of the successor languages, meaning is there going to be something after C++ or what's the new version look like? Some of these successor languages are purely to try out ideas and help evolve the language of C++. So in that way, C++ code is likely to exist for a very long time. I'm talking on the scale of decades in which there will still be jobs for C++ programmers. But what the chatter has been about with languages like Cppfront, Circle, Carbon, some of these other dialects and so on, are being proposed to say in the same way that you might think about something, the analogy that folks have been making of JavaScript and TypeScript, meaning that JavaScript still exists, but maybe there's a TypeScript type of language that compiles down into JavaScript, and then that's what's run. So that's kind of the idea or my understanding of Cppfront. So with that said, let's go ahead and just investigate a few different things here. You'll see it's something that's being actively discussed here on things like Reddit and Hacker News and so on, and even from Herb Sutter himself here. So let's go ahead and just click on and visit his website here, in which he's got some different updates in the language. So you can very much see that this is something in progress. But we can see some things like it looks like there's like reflection and so on going on. There's metaprogramming stuff here. So interesting things here. And we're seeing that there's a lot of new contributors and folks working on this. And this is a post from 2023 here. So, over a year ago at this point, just one of the Google search results. So with that said, I want to go ahead and just start from the GitHub repo, and then we'll try to explore this a little bit. This is available on Compiler Explorer or godbolt.org. And you could go ahead and select the Cpp2-Cppfront here. And you'll already notice, or one thing that you can notice here is that here's the Cpp2 code on the left, and on the right side, you can see it's just compiling down to C++. So it's kind of interesting to see as well, maybe even just as a study or an experiment that, here's your main function, and here's, maybe the correct way or a way. Let's go ahead and just rearrange this a little bit. To write your C++ code here. Okay, so this is C++ that you could use here. Now, depending on if you're following along with the latest C++ developments, right, you can have trailing return types, auto, so it can deduce the type for main and so on. So as the function prototype. So again, you can see here, that this is just legal C++ here. So interestingly, what we can do here is if we can't get this working, we could type out the examples here and then just use a regular C++ compiler to run this code. Okay, so kind of an interesting idea. I've been wanting to dig into this for a while here. I've seen a few of the keynotes from Herb Sutter about this in person. So yeah, let's dive into it. This is my first time trying it after just hearing about it. So there is some documentation available. We're mainly going to go from the GitHub page, but it looks like we've got some nice stuff here that we can explore here. So let's just try to understand a little bit. This is very much, again, an active project. Things could change. It's an experiment. So again, I think it's fun to look at this point here, and maybe we'll look back on this video here some time and see some of the evolution here. But let's just try to understand what's different about this project. So in short, it aims to help evolve C++ itself and not to be a C++ successor. Okay, interesting. I guess we're talking a lot, or there's a lot of chatter in the community about C++ successor languages. And the reason this has come up because C++ is a very large language as far as the different things that are involved, the compiler implementing it, and so on. So folks are kind of exploring around and trying to tease out what are going to be the next big features in the language, or how could we engineer this in a way that maybe get some of the features that other languages have to continue and allow C++ to be an evolving language. All languages, as you've seen in this series and we've studied, have evolved. So that's just something to keep in mind. So let's kind of clear this up, I guess, because I think even as I've mentioned, it is a C++ successor. That's how I think of it. But this is explicitly saying it's not a C++ successor. So what it isn't. It's not a successor or alternate language with its own divergent or incompatible ecosystem. So again, I think that's an important point because as we can see from Godbolt here, right, if I can compile this down to C++ code here, I can run all of my tools, static analysis, dynamic analysis, all my tool chain, and again, just treat this as regular C++ code. So I don't have to change anything, but maybe on the C++ front end or the compiler here, right, I can write my code in a default safer way, maybe an easier syntax or something. So that's kind of an interesting philosophy here. Okay, so it says, for example, it does not have its own non-standard incompatible modules or concepts that compete with the C++ standard features. It doesn't replace your C++ compiler or other tools. It doesn't require any changes to your standard C++ compiler or standard libraries. Again, so you just get to keep using all the same tools and so on that you have. What it is, C++2 aims to be another skin for C++ itself, just a simpler and safer way to write ordinary C++ types, functions, objects, and a faster way to experiment with proposals for a future new standard C++ features in a simpler compiler and syntax flavor. Okay. And because I guess you're just focusing on the front end, you don't have to worry about, basically with the language, you just have to worry about how do I translate some concept into C++ code, right? So I'm just basically writing the front end that can parse this and generate valid C++. That's my target. And then the C++ compilers can worry about what they're good at doing, meaning translating this into some intermediate representation and then ultimately assembly code. So I want to go ahead and do just a little bit of a history lesson here. Again, this is called Cppfront or Cpp2-Cppfront here. And let me bring in another window here, this Wikipedia page here, which talks about Cfront, okay, just so you can understand where Cppfront comes from. So Cfront was the original compiler for C++, which was known as C from classes. And that's what Bjørn Strustrup, the creator of C++, or the first real creator of it, wrote this Cfront, a front end, which translated C++ code to C. Okay, so I mean, if you don't know, and maybe it's worth studying, right, you can write object-oriented code in C. It just happens to be that, with a compiler that can understand, a different syntax, like in C++, it's a little bit more convenient, and perhaps there are more expressive ways to do things with objects. But at the end of the day, you can translate those concepts to C. So that's exactly where this sort of language came from. So that was sort of the idea that the Cppfront compiler would generate C code, and then eventually they'd kind of make it its own self-hosting thing and implement the C++ compiler in Cppfront, so you could kind of get away with get rid of the Cppfront sort of side of things and just have a compiler that took C++ code and generated an intermediate representation, and then ultimately the language itself. So anyways, just a little bit of history for the name here if you didn't know or understand where Cppfront came from. I believe that's what this is sort of an ode to. So anyways, what that means is Cpp2 is just another skin for C++ itself. Okay, so it's just generating C++ code. Okay, again, in a safer, simpler way here. Let's see what we got here. It seamlessly uses C++ standard modules. Okay, we already looked at this here. It works with all the compilers. And then there's zero overhead as far as the integration. So, I mean, this seems like, again, when you talk about the C++ language, like a lot of folks think it's dying. And I don't know. I don't really want to comment on that because, you know, you could be sort of wrong in history. But what I think it was interesting is C++, there's just a lot of code that has been written in the language. And I don't think, again, that's going to go anywhere in the same way that we've looked at in this, series, languages like COBOL, where there's still, COBOL code being written and maintained that's, 50 plus years old in some cases. So I think that is sort of an interesting approach for, again, evolving the language or having a space to play around with it. Okay. I think there will be new C++ code bases for a while. That's just the reality of things. So let's kind of start looking through the documentation and see if we can get this set up here. And again, I would sort of point you towards the 2022 talk from Herb Sutter at CppCon that did a really nice job introducing this tool. And then there's been some, again, the same sort of analogy of thinking about this like a TypeScript compiler in the same way that TypeScript generates JavaScript for the web, but in a safer, type-safe way, and so on. Because again, the emphasis as to why folks are wondering, are there going to be other programming languages that take over the domain? And again, everybody has an opinion about this, but it is kind of interesting if you can incorporate safety and different checks by just having a new syntax and having that front-end compiler do a lot of the checking for you. So it's a very interesting time in C++ evolution, I think, as a language, where we're seeing these experiments like Cpp2, Carbon, Circle, and so on. Okay, so anyways, with that said, let's see if we can go ahead and get this working here. So let's see here. We got a file here. Hello, Cpp2. And let's see here. So this is just sort of from the wiki here. I think there's some other interesting quotes here. Yeah, Björn himself said this. Inside C++, there is a much smaller and cleaner language struggling to get out here. And that's from 1994, which is kind of funny. But what I'll say about this, I don't want to misconstrue this quote, because one, it was 30 years ago at this point. The second thing is, I think this is also, again, I got to see what the context is. I think he's since said some other things about this. But interestingly, I think there have been some experiments and discussions about, some of the ways to evolve and add some features and so on of C++. But anyways, so it looks like there's a goal here to prove Strucip right. Meaning, can we find the sort of interesting subset of C++ that we could present as sort of a front end for programmers here to make it 10 times simpler, but just as powerful. Because the one thing C++ gets right, I think, is that it does give you full control of your code, right? It doesn't give you any sort of restrictions, whether that means things like safe or unsafe code. It doesn't sort of default you into anything other than, in a way, it's almost acting like a language as a sort of portable assembly with object-oriented programming, right? Sort of the same way as C is looked at or was looked at historically. So that's kind of interesting, again, for all the applications or domains like finance and gaming and scientific computing and so on, which have embraced C++. And I think will continue to, at least in those domains, amongst some other like high performance areas or other domains where power consumption and performance and these types of things matter, which you could argue that for pretty much every domain. But anyways, so what is kind of interesting here is, again, thinking about the evolution process of this language, and that's what we want to explore today, Cpp2 here. Okay, let's see. Let's see what else we got here. I think these are some interesting bullet points. So we got freedom to make any desired improvement without breaking any of today's code. I mean, I think that's the big sales pitch. I mean, when we think about language popularity and why C++, for instance, was able to gain a lot of traction, right? It was able to build off of C code bases, right? A C++ compiler could, I mean, this has almost been 100% true. I think there might be still some maybe some tiny differences between C and C++ code today if you're looking at like C20 or something. But largely speaking, you can compile your C code base with a C++ compiler. Okay. Again, that might not be true in all, like there might be some edge cases and so on. If you're looking at like C20 or something. But that's kind of an interesting way to evolve a language and also get adoption of a language if you can make use of all of your old code, right, without having to switch. So then you can kind of gradually migrate, and again, that can kind of make sense here. So Cpp2 itself is designed to take all the consensus C++ best practices that we already teach and make them the defaults when using syntax 2. Okay, so this is the, again, here is syntax 2 on the left, and it generates, what we think is the right thing to do, right? Which is something like this with our functions, right? No discard, so making sure that we, don't get rid of this value. Using auto, we like the trailing return types. I wonder if this will even become print line someday, or with std format or something. But anyways, the different things that we've learned how to do in C++, all the best practices over years and years and years, all the core guidelines, and yeah, just have that code be generated by doing this function declaration this one way here, or rather the main here, as I have here. Okay, so from the documentation, let's see. So some more examples. Writing unsafe typecast is just not possible with Cpp2 syntax, and Cpp2 can change language defaults to make them simpler and safer. Yeah, and I mean, I think this is interesting to experiment with, right? These are the types of things that a lot of newer languages, D doesn't let you make a lot of these typecasts. Other languages, again, you have to explicitly cast with a keyword again. So, these are nice things that languages have. So it is nice to see that that's the type of thing we're thinking about with Cpp2. Let's see, you can always break the glass when needed to violate the guidance, but you have to opt out explicitly to write unsafe code. Interesting here. Let's see what this design note is here. Okay. And again, you can very much see that this is work in progress stuff here. So I don't want to hold anyone who's developing Cpp2 to, hold themselves to some sort of, again, this is very much a evolving language. But again, as I mentioned, it'd be fun to look at. Let's see, perfect link compatibility, always on. Perfect source compatibility, always available. But you pay for it only if you use it. So again, yeah, it's just going through a normal C++ compiler. And you could call the other functions, whether it's in Cpp1 syntax or the new Cpp2 syntax. You can mix them and match them. So yeah, that's kind of cool. I mean, at the end of the day, since it's compiling C++ code, you get that flexibility. It's kind of nice too when we look at the evolution here, or just think about it for a little bit, as a programmer, to say, well, I've invested a lot of time, learning this language and the tricks and optimizations and specific libraries and so on, that you can migrate and not sort of lose that knowledge. Again, as I found, it's hard to just switch a big code base or a big project to another language, right? It doesn't really happen that often, right? So legacy code bases are a powerful driving factor, in my opinion, of language, the language that you end up staying with for a long time. So anyways, let's get a look at here. And again, here's the history lesson, which we talked about with Cppfront. Let's try to build this here. So it says it builds with any recent C++ compiler. We'll go to the GitHub repo here, and then run one of the following here. Okay, so I should just be able to clone this and run the Cppfront here. Let's see. I mean, you can literally see there was work being done here 7 hours ago. And I'm just recording on a random day in June of 2024. So let's just go ahead and clone this here. Let's do git clone. Okay, so we're going to grab the repo, go into Cppfront, and let's see what we need to do here. Let's get the documentation in front of us. How do I build this? Okay, so I have various versions of GCC and G++. Just show you my version 11 here. And I got to go into the source folder, and I just run this command here, and it's going to build. Okay, let's see if this works. I'll be impressed if that's all there is to it. And then we've got Compiler Explorer as our backup here. Okay, that's it. Let's see. Oh, there's an interesting footnote here. And Herb, I remember buying one of Herb's like ANSI C++ guides probably 20 years ago at this point, or close to that. And just being fascinated. Herb's a really nice writer. I really enjoyed his books. So it's funny if he comes up with something that's even better when I already enjoyed, some of his books, which I still have. That's great. So yeah, having the right sort of defaults and getting rid of the gotchas and inconsistencies, of a language that's evolved over almost 50 years. That would be really great. I think people want that, and easier and safer by default. Yeah, and then you can always opt in and do the other stuff if you need to. So anyways, I think this gave us a Cppfront tool. Cool. That was it. So easy setup. Well, let's go to Hello World. Let's just try some of this out here. Let's go ahead and get our tmux ready here. Let's try to run a Hello World here. One-line starter. As a complete program. Okay. No include required. Okay, I like that. Let's call this hello.cpp2. Okay, I like the extension. Main, I guess that's a function here. I wonder if these spaces matter here. Hello world. I wonder if the Cpp2 front compiler was just smart enough that it just includes, I wonder if it's actually looking for these standard namespaces. I guess we'll find out here. So let's run Cppfront. Okay, before I even look at other directions here, is it the same? Okay. Oh, interesting. Let's see here. Now, when I got this program file, did this just generate me a CPP, or did it give me a binary? I'm assuming it gave me a okay, yeah, it just gives me the file here. Okay, so I gotta, here, let's remove that. And let's just call this hello.cpp. And it actually opens hello CPP. Let's make this a little bit bigger here. Let's see what it actually included here. Okay, so it's got a util here. Okay, so it knows about that, I guess. And it does the function declarations for me. It's got the function here. Let's see, what is Cpp2 util? Okay, vim Cpp2 util. Okay, that's including a directory back here. Let's try to follow this chain here, just to kind of understand what it's doing here. Utilities. There are two kinds of utilities in this file. Entities in the namespace. Okay, for Cpp2 itself, and some implementation stuff. Okay. Interesting. Okay. Okay, and they're doing some stuff with C++23 with imports and so on. Okay, so it's bringing in some of the files here and so on. Okay, so we've got something here. Let me... Okay, this might be getting ahead of ourselves here. So we built this here. Can I just run now through G++? And I probably got to use C++20, hello. And then I could just build and run my hello world. Okay. So it's two passes. Generate the source code. And I'm imagining if we have a simpler, safer syntax, we can do static analysis more easily on this subset here, and generate some C++ code. This is pretty cool. I wonder if we should take a really advanced example just to see how far along this is. I'm trying to think of what code I have. This might be a fun experiment if you're following along. Just take the most complicated piece of code you have and see if this works. If it does, that's brilliant. So that's pretty cool. Okay, let's keep exploring here. Yeah, let's do something more interesting here. Okay, let's just keep adding on to this. Okay, so this is going to be a multi-line function here. I wonder if it's always deducing the return type. Right, we should be smart enough to do that. Okay, so we're going to do words and the type. So again, this is flipping things around. So we have the type here, and then, you know, the thing here. Because I guess I could do like words2. I wonder if that's going to work here. And then I can assign it. Hold on, I'm just going to spend the whole video breaking this thing. Because it's kind of neat here. Okay, let's see what kind of errors it's giving me. Error, invalid statement. Okay, yeah, I can't do this. I don't know what it would be assigning, I guess, here. Here. Let's just follow the example. All, okay, so yeah, all Cpp2, so this is okay. Passes safety checks. Okay, so I'm going to be really curious about that. Let's just make a mental mark about that. Here, I'm just going to put this to like starting or something like that. I'm really curious what these safety checks are going to be. Let's see if we run into something like an out of bounds axis. Actually, let's just, okay, we got to figure out how to do an array here. Word 0. And again, we could just do, oh, hello here. Okay, let's write a little helper function. And this is neat here. I could just put it at the end. And we're going to look at this code again as we do this so we can see the translation. Hello, message is going to be the argument type and the data type here. Oh, interesting. Okay, so for these one-liners, I could just do equal, you know, different spaces. That's nice. I like this. We've got like a shortened syntax, so we don't have to, you know, constantly type out curly braces. Ooh, this is neat. Right, we just talked about, like, if you're watching my C++ series, we just talked about std format, so you could just actually put stuff within the string. I like that. Again, it's kind of cool that Herb, and I imagine some other folks who are contributing to this, right, they know all the like new cool C++ stuff that maybe some of us, like myself, are catching up on. So they're like already integrating all these features right into the language, which is cool. Okay, let's go ahead and call our hello function. Words, let's access the array. Hello, words 1. Okay, let's do that. All safety checks passed. Let's compile it. Let's run it, and there we go. Starting, hello Alice, hello Bob. Beautiful, okay. We're using our C++ knowledge, so string view, which again is just going to take a look at this. It's like a const ref string, I guess. Okay, so that's neat. And as mentioned, it's kind of nice to just be able to put these functions wherever I want. Let's look at that hello.cpp. This is the code that was generated. Yeah, it's putting all the function declarations for us at the top of our code, so we can just like put this at the bottom of our code. I mean, many modern languages do this type of thing. Whether they're transforming the code or not, I'm not sure if they're doing the same thing here, but that's a really easy thing to do, and then we don't have to worry about like what order we put these things in or whatever. You know, it just takes care of a problem. You don't have to worry about the function declarations, which is kind of cool. Let's see here. Other interesting things here. Okay, so we got our like standard vector here. Okay, this is an interesting clue here. Cpp2 assert in bounds, literal. And another Cpp2 assert. So let's try one of those safety checks here. Let's access words at 18. Now, clearly there are Alice at the 0th index and Bob at the 1st index. Will Cpp2 find this here? Okay, so safety checks are passed, but if I compile this code, if I run it, I'm assuming I'm going to get like an assert here. Yeah, bounds safety violation. Out of bounds, access attempted at index 18. Min-max range is 0 to 1. Cool. This is some nice error messaging here. I mean, it's telling you what the range is. It's telling you where you went out of bounds. And there's probably a way to like turn those types of things on and off. I wonder if there are. I guess we got to look here. We'll go to our table of contents, but or I imagine that could be something that you do right in the code generation phase. to turn off these different assertions here. That's pretty cool. Again, as some of you know, I also use the D language a lot, so you can turn on and off bounds checking. By default, it's on, and it'll throw an exception. So something kind of similar to what this is doing, which is cool. I like that this is doing, a lot of the interesting stuff for me. Now, this is kind of funny here. What's it doing here? It's doing a move at index 18 here. Now, on this one, it's not doing anything. I'm just getting 0 and 1. That's kind of interesting. So maybe something to keep an eye on. And a lot of these functions here, I mean, I wonder if they're going to have to, how much stuff they're going to have to implement here, because they got the Cpp2 string here that they're doing. Okay, that's kind of interesting. I guess anywhere where we could do this string conversion, it'll just handle that. Okay, so I mean, this is going to be kind of interesting here. This compiler here. Okay, let's look at some more of this stuff here. So it already introduces a few of the examples, this code here. Consistent context-free syntax. Cpp2 is designed so that there will be one general way to spell a given thing that works consistently everywhere. I like that. I am all for having programming languages that are very expressive. I think that is useful. But from an implementation standpoint, if you're designing a compiler or something, it's really nice, for your tools, for the speed of compilation, if things are not ambiguous in the language, for instance. So that makes sense, that we sort of just pick the right default way to write things out. So again, I think that's why we have the name, kind, and statement. There's something you can do. This is... let me just type out in a comment here, C and C++ example. And again, C++ meaning Cpp1, where you can do this syntax here, P, comma, P1, P2 equals, 7 or something like this, which is kind of ambiguous here. This is a classic example of well, is this a pointer, and was this also supposed to be an int pointer, or is this just an int, right? So, the truth is, something like this, let's see if this actually compiles here, just so I can illustrate it here. Yeah, still works, still runs, and let's go ahead and preview the code here. I wonder what it does with that code. Oh, I think it actually got rid of it, because that's smart enough. Okay, it's smart enough, so it is optimizing code we don't use. That's kind of cool here. Okay, maybe this tool's a little bit further along than I thought, Cpp2. So that's kind of encouraging. Because the thing that I wanted to show you, I wanted to see what it would do with this. And right, this is the pointer. This is just regular integer. That's why we can just assign it to 7, right? Because if I do this, the address of, I don't know, let's just create some other variable here. Oops, sorry. Let's save that. Oh, maybe I didn't save here, but let's see what happens here. Yeah, let's see. Invalid statement encountered inside a compound statement at X. Oh, cool. Let's see. Invalid statement. Is it because I didn't assign it? Let's see. No, I think it is. Invalid statement encountered inside a compound statement. Line 5 here. Is it just? I wonder if it's this here. Let's comment that out. That's a wrong line number, but I can't just do int x equals 9 or something. Oh, I know what I did here. Already breaking my own rules here. I think it's gonna be x int, right? Something like that, right? Because we're in Cpp2 land. There we go. I see. So yeah, I don't even know if I'm gonna be able to write this example. So this one I'd have to do p1 colon p2, and can I do int like that? Let's see. Tab multiple. No, I can't do the compound statement. Okay, I actually like that. I don't want to put two things anyways. I think it's better to, I mean, it gets rid of this error here. Where in C++, that can be ambiguous here. Let's see what else we got here. What error is it giving me at line 6 here? P1. Error, local variable P1 is used before it was initialized. Oh, that's probably just because I have equals 5, something like that. Okay, cool. So you have to initialize your variables. Simple as that. I wonder if there's like an unsafe mode. Of course, you can always just mix in the C++, and that would be the unsafe where you don't initialize. Again, there's reasons to not initialize something if you have a large buffer or something. But anyways, okay, cool. Let's kind of keep looking through this here. Let's see here. Got the name, kind, statement. The colon is pronounced is a, okay, and the equals is pronounced defined as, okay. So words is a stood vector defined as this. Okay, I like that. That's actually a nice way to think about the programming. I'm actually just going to copy and paste that in here. Is a, just so I can kind of speak the language a little bit better. So words is a vector defined as this. I like that. It's mathematical, but it's also just reads as English, left to right. So that's an improvement with this sort of syntax. Again, I've grown to like this a little bit more. Again, I'm used to the type on the left side. Again, that was probably just something easier to parse back in the day, but I don't know, we've evolved from that as far as compiler technology and parsers. Or I shouldn't say we've even evolved from that, because there was like, Pascal style declarations available way, way, way long ago. So it's not even like a technology thing. I think it's just how we maybe thought about it. All right. So anyways, main is a function. And that kind of even reads better too. Defined as, something taking no arguments. We got the vector and the hello function. Okay. All grammar is context free. In particular, we, the human reading the code and the compiler, never need to do a name lookup to figure out how to parse something. There's never a vexing parse in Cpp2. For details, see unambiguous parsing. Cool. I really like this from just a historic point of view. It's hard. You can find in like history of programming language, the like retrospective language analyses. Sometimes you could find on like YouTube or other sites, video interviews with the designers. I like having the design notes, right? And in C++, we have things like the core guidelines that tell us best practices and so on. I think that's really useful to know the why something exists. So anyways, I think that's just a nice note here. So let's see. Simple, safe, efficient by default. C++2 has contracts. Okay, cool. Which is tracking the C++26 contracts. Inspect, pattern matching, string interpolation, automatic move from last use, and more. Cool. Declaring words using ctad, the class template argument deduction, to deduce the types here. Yeah, right. In C++, normally we would say like int or something here. Does that work here? That does still work here. Okay. Oh, interesting. Oh yeah. That's my my bounds check is failing here. I wonder if I just didn't. Let's see here. Let's comment that out here. Safety checks pass. Oh, do I not? Maybe I don't know how to comment things out here, because I am still getting that error here. Hello words. What did I do here? In expansion, word 0. That's weird. It's kind of crashing on me now. I wonder what I did. Invalid initialization of reference type. Let's see here. So our message isn't too bad here. Expansion of words. I wonder what I did here. Let's get rid of this here. Use Cppfront. Try to rebuild. I guess I broke something with this. Again, we'll have to look at the syntax. I mean, it's refreshing enough here. Let's get it in a working state. There we go. Still working. So I wonder how I explicitly put the type here. Do we have to do like words, colon? Yeah, how do I do generics? We got to see that. Bounds checked by default. Okay, cool. That's something we talked about here. And that's true for any other similar subscript of something whose size can be queried using size and size. And begin returns a random access iterator. Okay. Okay, cool. So for our iterator types where we have like begin and end, and it's just accessing like an index, it can bounds check. Cool. And then this is using the string interpolation, which lets us pop in a variable here. Cool. Some defaults. We can omit writing the void. We can omit the curly braces around single statements. And we can omit the in on the message parameter here. Well, let's see here. Cpp2 has just 6 ways to pass out parameters. The most common ones are in for read only. Okay, so again, yeah, they're using like from shader languages, or D has stuff like in out variables. This has copy, out, move, forward, in, and in out. Interesting. Okay, I actually like that. Again, I like having these qualifiers here because they're easier than overloading like the ampersand symbol or the asterisk and all these different things here. Again, I think that's really nice. Order independent by default. Yeah, it doesn't matter which way we have the functions. Seamless compatibility with interrupt. Yeah, we could just use cout, string view. It's kind of nice. I mean, you just write code. You don't have to worry about like what a library is and bringing it in and so on. It looks like it's just including, yeah, it's including the standard library. And I imagine we could get rid of away with this in like C++20 and 23 with modules. Maybe there are smarter ways too to just like include the things that we need. So that's pretty cool. C++ standard library is always available. We don't need the includes. Okay, there we go. Yeah, that's really nice. Let's see. A full C++ standard library is always available by default if your source file contains only syntax2 code and it compiled using Cppfront -p, short for pure Cpp2, or im. Okay, that just brings in the whole standard library. Okay, so it's constantly being updated as well. So that's pretty cool here. Yeah, let's do... Okay, here's the resulting file here. Okay, all compiled code. Okay, so we've kind of defaulted into C++20, which, in my opinion, again, this is just my opinion, C++20 is actually a pretty nice language. If you're, able to use like class template, here's a, okay, let's just do a regular like C++ file here. Okay, I still have to include or import the library here. I can do main with the trailing return type, although it's going to be an int. And then I can do, let's see, return 0. Let's go ahead and split this window one more time. I can include vector. So this is just the C++20 standard code here. And then I can do vector words, Alice and Bob, something like that, and keep repeating. Now let's actually make sure that this works here. Cpp20. Let's see here. I gotta do standard equals C++20. Let's see. Oh, what did I mess up with the trailing return type? Oh, I think I need to put auto. I forget that. Oh, so we don't even need to do auto in Cpp2 here. I mean, again, this is just cleaning things up a lot here with Cpp2. But why C++20 kind of from a design standpoint? Right, if you're going to build a new front end for C++, you kind of want to pick a version of the C++ language that's relatively recent where you get these conveniences, right? Like the class template argument deduction. Although I think that's been available since maybe like C++ 17 or 14, or maybe even 11. I can't remember. You get the trailing return types, but you can get rid of the auto. So it's a nice place to start as far as design, and maybe that's just a lesson for programming language designers to work from a recent evolution rather than going all the way back to like C++ 98 and worrying about supporting that. Okay, let's just go ahead and quit some of these windows here. Let's get back to our Cppfront example here. Gotta do it again. Cppfront, and we're doing our, what do we have here? Hello, Cpp2, and outputting hello.cpp. Okay. All right. So again, yeah, you get CTAD, you get the automatic bounds checking. It'll put in the move semantics for you. Again, I like that. I like performance. If the compiler is smart enough to do it for me, that's great. String interpolation and other stuff here. Okay. we got to look, I guess, at the marshalling with other calls here. Oh, okay, never mind. It just says ordinary direct calls to existing C++ code. Okay, so I guess if it's just looking through some code that maybe we import, it'll just handle it, which is cool. Okay, and we built this here. Okay, finally just build hello CPP. Okay. And oh, I see. So you might want to also include Cppfront includes. Okay, for like the implementation stuff. Okay, fair enough. Let's go ahead and see here. Okay, so I think we've explored an example in pretty thoroughly, but let's kind of keep looking through some more examples here. So let's see what their integration plan is here. Copy CPP files to the same, like, yeah, Cpp2, like we just sort of intuitively did. We want to do C++20 and then set up a custom build. Okay. So, I mean, this really does have a nice path for migration here and updating our code. So I'm quite pleased with this. This is really nice here. Okay. Let's see what else we got here. Let's see some common concepts. So we're running, we're starting to get close to the hour mark. So let's see a few things here. No parameters, one parameter. The type of args cannot be explicitly specified. It's always Cp2 args t, which behaves like this. Okay. Hey, that's kind of nice. Okay, so it is what it is there. You just pass in args. And I wonder, I think on some, right, on some systems you could like pass in environment variables and stuff and read those. So I wonder how that works. But anyways, okay, 4 statements. Let's do one of these here. Oh, we don't have qcore, but we could still play around with this. So let's add in args, and let's do a for loop for args. Do arg. Okay. I'll just put an end line here. I don't mind streams, they're okay, but it is nice to have the string interpolation stuff like this here. Okay, so let's go ahead and Cppfront this guy. Let's compile it. Hello. And let's just run it here if it compiles. Okay, so it compiles and runs. Let's give it some arguments. Subscribe and like, whatever. Okay. So get our program, subscribe, and like. Okay, cool. So nice for loop, no parentheses. That's smart enough. Now, can we put those in here? Or is it very like strict here? Let's see if my old... Oh, yeah, it doesn't like that. Okay, so we got one way to do things. Okay, so kind of nice, not ambiguous. The other reason, again, as I mentioned this briefly, for having like context-free grammars that aren't ambiguous or sort of like one right way to do most of the things. If I'm building tools, it's really nice if I can just like hack together a regular expression that looks for things that have like for, word, and then do, and then, parentheses or whatever. I wonder, can I do like this? What if I gotta have multiple of these things in here? No, okay. Or maybe, but I just don't know how. I'm just guessing. So just kind of playing around with this. Okay, comments, we know about lists and commas. Okay. Let's see what we got here. We want to print a list here. Again, you get a lot of these one-liners here with the short syntax. I actually really love this. The short method or short function call syntax available in some languages where you don't have to write curly braces if it's literally just a function declaration followed by like an equals sign, or in D8's equals with an arrow. I really like this because you end up not cluttering your code. It kind of encourages you to write more of these short little functions. So there's just something nice about it here. Okay, here's our array. Okay, so let's try to understand our for, where I put in 2 things. So this is our like range, and this is how we're accessing each element. Okay, let's do a little bit more here. So we got the array, of course. Here, array is a array, and hey, this is nice. We're just using different syntax for arrays, like little curly braces here. Or I guess that's a list initializer. That's probably what it's translating it to. Maybe. Let's see. Let me scroll up. Parentheses for most lists, brackets for subscript, and angle brackets. Okay, still remain for the template arguments. That's okay. But that's kind of nice here. And let's use our 4, 0, 1, 2. I guess it's the indices in whatever we have here. Print E an array. E. Okay, so we're accessing the subscript. Hey, I wonder if I can just write this function locally here. Print. Okay, it's going to deduce the type for me with the template arguments. Okay. T is a type. Okay, whatever that is. U. And then we're just going to say equal cout. TU. Okay, let's give that a try here. Okay, so local functions like print are not currently supported. Write a local variable initialized with an unnamed function. Okay, so that's something that they're going to work on here. Local functions, maybe. Okay, because I guess they're going to have to make that a lambda, but we can just stick this like literally wherever we want, right? Because the Cppfront tool will move it wherever we need, which is great. Let's run this. Let's see, we got our program. Subscribe and like. What did I... Oh, okay, sure. And I got 0A, 1B, 2C. Okay, so 0, 1, 2. That's the first part, and then I accessed my array for 0, 1, and 2. Okay, nice. All right, let's look at some more features here. Reserved keywords. Okay, very few globally reserved words. Yeah, we don't want to conflict with other code. Type, struct, enum, and new. Okay. And then some fundamental data types. Yes, I actually like these. These are the types of things, like if you ever have read LLVM, like intermediate representation, or in newer languages, you also see these types. I think Rust uses something like this. Again, it's been a while since we did our Rust video. But you just have the, prefix for the variable int and 8 and the width. I like fixed width types. I think they make sense. It's clear. It tells you what assembly is going to be generated. And it's easy to, search for. So yeah, we want to use the fixed width types here. And this is a lot easier on my hands than typing this out. So again, it encourages me to use these things. Yes, I know I can use like using or an alias for this, but again, I like it built in the language. Yeah, I like these as well. Let's see, our type qualifiers. Okay, they just go in front. So P is a const pointer to a non-const pointer. Okay, something like this. Okay, putting these stars next to each other is always tricky, but yeah, there you go. Literals, operators. Okay, let's see some other stuff here. Let's just kind of move along here. Try to see some more code examples in the last few minutes. Okay, generic function to log something. Okay, we're just using the parentheses here to kind of clean things up. Yeah, it's looking pretty nice to me here. Let's see here. Hello name. Generic function to print hello underscore 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 exclamation for any printable type. Hello. Okay, there's the like generic thing here. This is going to open a file. Oh, fopen here. Okay, so we're using like C function calls here. Or I guess, I mean, this is in the standard fopen. Okay, but maybe from the C lib. Direct calls to C non-member functions. Okay. Using universal function call syntax and safe string interpolation. Okay, cool. Yeah, string interpolation gives you type checking on the type of stuff that you're printing out. So that should avoid, any type unsafeness. So if I just like pass in an integer or something random into any of my like file IO stuff, it'll check this to make sure that name is a type that it can print out, I guess, successfully. Okay. Okay, so this is kind of interesting here. Okay, and we're getting some other stuff from like other languages, like the don't care, wildcard. If we don't care to write to the variable and just sort of deduce it, yeah. That's kind of cool though. Oh, that's deducing the actual type. Okay, I was gonna say because we use underscore sometimes if we just want to throw away a value, but that's like auto or something. Okay. Yeah, cool. This is kind of useful for like pattern matching too. I wonder if they use that. Okay. All right, we got a few minutes here. Let's take a look at some of the like I don't know, like one example from each of these, just to get us excited about, if you want to like take a deeper investigation or try this out. I think this is pretty cool. I'm pretty excited about this. Let's see some different functions here for the aliasing. Okay, let's look at object initialization for classes. What I'm really excited about is if I only have one syntax for initializing something. Let's see. Let's get to initialization. Guaranteed initialization. Yes, every object must be initialized using equal before it's used. That alone is going to... I think uninitialized variables still... I forget what the stat is. I might have to Google that. Let me bring in another window here. Let me show you what I'm searching for. Use of uninitialized variables. Okay, so this is from MITRE. And I want to say these CWEs, so basically these common weakness enumeration, I guess. So vulnerabilities in your code. Sometimes they call them like CVEs or I guess sub CWEs in this case. I think uninitialized variables account for some scary amount of security bugs. So here you go. Here's your safe for C++. Now, of course, you can use static analysis tools to account for these, but you got to make sure you use these things. So it's nice that it's built into this front end here. And then an object in any scope can be initialized at its declaration. Okay. Okay, so that's being declared here. Okay. Anyways, heap objects. How do we do stuff here? Interesting here. Okay, so we've got like unique new. Oh, this is cool. Objects can also be allocated in the heap using arena new. Where arena is any object that acts as a memory arena and provides a new function template. Cool. Yeah, arenas, are basically a way that you could heap allocate memory, and then when it goes out of scope, you can just like clear that whole region of memory. If that's what I'm understanding that we have here, that's pretty cool. It's a good way to write like an allocator in games, have arenas. Let's see what else they're doing here, though. Here they're allocating, dynamically allocate an object owned by a unique pointer. Okay, so vec here is a unique pointer containing 3 values. Okay, I'll just pop in new there. How about this one? Dynamically allocate an object with shared ownership. Okay, I just do shared.new. I see. Do I have one here that does like arena.new? Okay, so that's another one. Maybe they'll add some more examples, but okay, interesting. Yeah. That's cool. So, these are cool things. Again, one reason to kind of pay attention or, to be watching this series, as I imagine you are, is just to get exposed to some of these new things. Like if you don't know about arena allocators or these types of things, that's kind of cool. So 2 memory arena objects are provided in Cpp2. Oh, I see. Okay, so unique.new and share.new are just arenas. I guess just this is their scope. Yeah, because vec is destroyed here automatically, which destroys the heap vector and deallocates or frees its dynamic memory. Okay, cool. Functions we looked at. Okay, and here are the parameters. In, copy. I really like this. I think every language should have this. If your language otherwise doesn't have copy value, or we call it pass by value. I like calling it copy value because that's what it tells semantics. Meaning when you pass an argument into a function, if the default for every case isn't a copy, then I think you need an explicit keyword. Something like this is better. I actually like that because to a beginner, it tells you exactly what's happening. Again, maybe I just have a bias towards this because I teach programming, and I notice a lot of folks, especially in C++ or other languages that have like reference and copy semantics, it can be very confusing when you end up with like an object getting constructed twice and you update it and you don't know why. These are things that you can find, but again, in large code bases, it becomes tricky to track. So you want to be kind of explicit here. So yeah, in is like read only, always const. So yeah, a lot of these things are similar to what's being done in D, which is a reason I like using that language. In, out, read and write from, out is like a way to get a value out. So that's like passing in a pointer or something. move, move semantics, and forward anything. Yeah. Okay. So you're perfect forwarding here. I like that. Okay. Yeah, we got to get into contracts and a little bit of the reflection stuff before we end this. We're going to go a little bit over an hour, folks. Hope that's okay. Thanks for paying attention. Okay. Pre and post conditions. I like that. This, I suspect, is subject to change. Again, it's experimental, but I think contracts are being actively worked on as of this recording in June of 2024. So yeah, basically when I have a function, I can write the pre and post conditions, okay, which are usually like predicates or tests. Same thing as a template constraint in D. We've seen these like pre and post or similar things in also other languages like Ada, which have contracts. So yeah, that's kind of neat. Okay, types. Let's just, here, I'm just going to scroll down. Let's see, how are they helping us be safer? Okay, so we've got the derived and the base type here. Okay, so we still have the things like override this. Okay. Yeah, this we might have to just like pause here. Let's see. Okay, maybe we went down too far. Okay, but creating your own types makes sense. Functions are public by default. I actually like that. Okay, if there's only one thing I need to say here, I like, well, let me see here. In a type, data members are private by default and functions are public by default. That's kind of, that's interesting. So some languages are sort of all or nothing. I wonder, comment below, again, some of you folks will, because we haven't gotten a lot of like the object-oriented programming. This might be the first language where I see this, that the members are private, which again is mostly what I want, and the functions are public, right? Unless you have a helper function. Most of the time that's what you want. So that's kind of a neat default. Yeah. I like too, what I was looking for is hopefully, since in C++ struct versus class doesn't really do anything, you're just going to have this. I like that we just have type here. Again, that's one of the most like confusing things in C++. I'm teaching it to new programmers. I'm like, here's this thing called a class, which maybe you know from Java. Here's this thing in a struct, which you know in C, and they're like sort of the same, but conventionally you use structs as like pod data types and all that stuff. Yeah, I like this here. Okay. Yeah, I just want one thing, new type. Okay, and we could do inheritance and so on. Okay, last topic. Let's get to it here. Meta functions, meta programming. What do we got here? Because I think this could be a real strength for the language here. Okay, so I can add attributes to functions here, like value, and then I guess I can introspect for this. Oh, no. Let's see. Add value, automatically generates default, copy, move, construction assignments, spaceship operator, a strong order comparison, and emits an error if you try to write a non-public destructor or any protected or virtual functions. Okay, cool. That's cool here. Yeah, I guess if it's a value type, we can just... Okay, we also have at name and so on. Yeah, okay, so we could discern between value types. Okay, I like that. That's built in here. Interesting here. So it's a quick way to tell the compiler what you should generate, because by default in C++, it just generates all these things for you. Behind the scenes, you don't see the code here. So you kind of want to be explicit about that. Again, I like that. And it's an easy thing to do if you want that. Let's see what other stuff we have. Generating source at compile time. Meta function applied to definition using at gets to participate in interpreting the meaning of the definition by inspecting and manipulating the definition's parse tree. Okay, so I've got this here. Applies at interface, which makes functions pure virtual by default. At print, which preprints the resulting parse tree as source code to the console. Okay, so there is some cool stuff here. I think we got to parse it a little bit, but there are these built-in meta functions to allow us to do stuff. And I imagine you get more of these over time, and they're quick to look at. That's kind of an interesting design here. And then you can see exactly what's going on here. Cool. Let's see what else we got here. There was like pattern matching and other stuff here. Let's see here. I think that was discussed in one of the conference talks here, and maybe we skipped over it because it went, we covered a lot in an hour looking at and playing with this language here. Inspect. Okay, here it is. Here, inspect. Let's see what the pattern matching. And one reason I want to look at this again, I don't know is emphasized if CPP2 is going to be the, the next thing in the evolution, but it might inform what happens in the actual C++ compilers. So, yeah, this pattern matching, I mean, it looks is 0 equals 0, is 42, the answer, okay, is int, integer. So, we're able to take this function, it's a generic function here, x of any type. It's going to inspect it. It's going to give us a value, or we're setting a value here. And let's see here. I mean, it's just pattern matching here, and then this is the no match, right? The discard or throw away thing here. I mean, this is pretty clean. If we ended up with something like this in C++ with like an is pattern equals or is equals and then like curly braces or something, I'd be pretty happy with something like that. So yeah, that's pattern matching, which again is a useful, concise way to do these kind of checks here versus an if or a case statement and so on, and against like different types and so on. So that's pretty neat here. Okay. Okay, so, I think we've given a pretty good look here at Cppfront. Hopefully we've done it justice. And again, if folks don't want to download and try this out, but, I did it and it was pretty trivial, which again is always nice when you have a project that's very active, right? Just a few hours ago. It just works. You should be able to get that built. Otherwise, you can play around with this on godbolt.org and see what's going on here, which is it's pretty cool. But overall, I'm pretty impressed with CPP2. I'd encourage folks to try it out, to read through it just to understand what the language is. And again, you'll probably get a better preview of the language if you watch in Herb's words himself, or for other folks who've been contributing to this project, if they're giving talks to you. That's what I'd encourage that you take a look at. So anyways, folks, if you've enjoyed this, I reference a lot of other programming languages, because I do C++, C, and D language, so feel free to check out courses.m.io if you haven't already, to check out those free lessons. Then I got a bunch of other courses and tools courses if you're interested in those. Feel free to check those out. But yeah, let me know your thoughts about CPP2. Do you think it is a something that you would download in your tool chain and actually use and migrate in your code base? I'd be really curious to hear from folks if this is something that they want to use. I've been excited about it for 2+ years now at this point, since I first saw the release, or about a year and a half, I should say. And what I can say is I'm impressed. I'm impressed with the smoothness of the integration and the sort of interop, which is nice to see, and the safety features. I mean, I buy into some of those. And I think this has been hopefully this has been an interesting video in this series, because this is really the first language, or one of the first, I should say, where we've looked at how do we like move a bunch of code into something new, in the same way that, we haven't looked at TypeScript yet, for instance, but that sort of family of languages. Again, as I'm trying to remember all the languages that we've looked at, I think this has been interesting. So anyways, folks, thanks for joining me on this journey. Hopefully, you'll let me know what your thoughts are. I'll look forward to that. And as always, thank you for your time and attention, and I'll look forward to seeing you in the next video.